Hello class. We're going to look at simplifying rational expressions. So just a vocab word, a rational expression is when you have two polynomials and we're dividing them. So we'll have a fraction and we're going to have variables in the denominator. So it could look something like this. There's one example. We need to keep in mind though that we cannot divide by 0. So our denominator cannot be 0. That is what we are going to call an excluded value momentarily. We also must have our denominator have a degree greater than or equal to 1. If our degree is not greater than 1, then we don't have a variable in the denominator. And that's part of our definition of rational expression. So, oops, I kind of jumped around. But this example, we said our denominator can't be 0 ever. This example, -3 would make our denominator equal to 0. And that's what we call an excluded value. So it's an x value. Remember, x is in your domain. So it's an x value where our function becomes undefined. And undefined in this case is just when your denominator is equal to 0. So we're going to do a few examples where we just find the excluded values. So we start with 5 over x squared plus 7x plus 12. Whenever you have a trinomial that's quadratic, we always want to try to factor it. So we have x plus 4, x plus 3 once it gets factored. And then in order to find those excluded values, we take both pieces and set them equal to 0 and then solve for x. So our first piece, x can't be -4, and our second piece, x can't be -3. Those are our excluded values. Okay, here's a couple other, and neither of these have any excluded values. This one doesn't have an excluded value because our denominator will never be equal to 0. 6 will never equal 0, so we don't need to worry about excluded values here. And this denominator will never be equal to 0 because anytime we square a number, it's guaranteed to be positive, and then we're adding 4 more. So a positive number plus any number will remain positive, so we don't ever have to worry about it equaling 0. Okay, here's a quick reminder, a power rule. When we are dividing and have similar bases, we can subtract the exponents. So here's a quick example. We have 3x to the 6 over 6x squared. I always simplify my numbers, my coefficients first. So 3 over 6 becomes a 1 over 2. And then if I simplify my x to the 6 over x squared, I subtract those exponents to get an x to the 4th. This 1 is unnecessary, so it's just x to the 4th over 2. Here's another one, x squared over x to the 5th. This time our larger exponent is in the denominator, so we know that our difference, once we subtract, will stay in the denominator. Exponent was larger on top, that's why our x to the 4th was up here. Exponent's larger on bottom, so that's why our x to the 3rd is on the denominator. Don't forget you must have this 1 on the top, otherwise it changes the problem. All right, our goal is going to be to simplify and then state your excluded values. So our original starts as 4x plus 8 over 8x plus 16. In order to simplify, our goal is going to be to factor as much as possible. So in the top, we can take a 4 out. In the denominator, we can take an 8 out. So I did that. And that becomes clear that you can cancel off your x plus 2's, leaving you with a 4 over 8, which we know simplifies to be a half. When you go to state your excluded values, you have to go to your factored step. So we're going to go right here to state what is our excluded value. So I'm going to look at it. 8 will never be 0, so I can ignore that. But then I said x plus 2 equal to 0 and solve. So my excluded value is -2. Maybe. Okay. Just some more examples. Simplify and give your excluded values. You can factor a 4 out on the top, leaving you with a c squared minus 16, which is a difference of 2 squares, so it factors to be this. C plus 4 on the denominator. Your c plus 4's cancel, leaving you with a 4c, a 4, and then c minus 4 in parentheses. Your excluded value would be -4. Okay, c cannot be -4. That would make your denominator 0. I'm okay with either of these as a final answer. If you want to go ahead and distribute, that's fine. If you want to leave it as 4 parentheses c minus 4, that's cool too. I'd like you guys to simplify this expression and then give the excluded values. And one more example, it's a little lengthier, but we're going to have a trinomial on both the numerator and the denominator. So whenever we have a negative coefficient or a leading coefficient that's negative, I recommend factoring out a negative. So I did that in this first step. It just makes your factoring job a little easier in the long run. So I factored out a negative, but you can also take a 2 out of everything. So I really factored out a negative 2. And then in the denominator, you can factor out a 3. Definitely factor out all that you can before you factor into parentheses so your life is easier. But then the trinomials factor as such. Again, simplify, and you get negative 2 parentheses x minus 3 over 3 parentheses x plus 2. And you get your excluded values from right here. So x can't be negative 5 or can't be negative 2.